In this video, we're going to walk through the process of imposing a design constraint on element stresses for MSC Nastran Optimization. We're using the same example I've done for the previous transient examples. Here on the plot is a history of the stress in the spring over time. MSC Nastran allows you to put or employ a functionality that allows you to pretend there's a stress in the spring. Here we see that at about 0.15 seconds, we have a maximum spring stress of 150 newtons per meter squared, or actually this is a 150 megapascals. Here at approximately 0.6 seconds, we have a stress of negative 150 megapascals. Right now, the question I want to answer by the end of the video, what value of the spring will produce a new stress plot where the stress in the spring is no less than 200 megapascals. Here, feel free to pause the video and look at the description of the model. This is the same one as before. As for our optimization problem statement, we have the same objective, same design variable, but now our constraint is different. We want to say that the stress in the spring again should be no less than negative 200 megapascals. And now let's walk through the process of doing this in MSC Nastran. Here in this directory, I already have my design model. This is something that may have been produced by Patran. It has a description of my design objective and design variable. I've already done this prior to the video. The focus now is to create this design constraint. So I'll click on constraints in my web app, and then I'll go and select modal transient response, and then I'll scroll until I find the element stress response. I'll click on the plus icon to create one constraint on element stress. This is where I can now begin adjusting my design constraint. Let me go ahead and look back at my optimization problem statement. So we have a minimum bound, a lower bound, if you will, of negative 200 megapascals. So here, simplest step, I'll go ahead and type in negative 200 into the lower bound box. Now as for the other items, we are working with a property type known as pbush. And you can tell this by looking inside of your BDF file or using your pbush processor to display the property type and ID. Here, the spring has a property type of pbush, and the ID is 1. And here, property ID, the placeholder, tells me to type in a value, 1. And as for the stress item code, this is where you need to refer to the MSC Nastran Quick Reference Guide. There's a chapter 6 called Item Codes. This includes all the item codes for a lot of the elements you're working with inside of MSC Nastran. It so happens that the cbush element item code is the one we're looking for. So I'm just scrolling until I find cbush. So now here in this column, I'm looking for the stress in the element's x direction. So that would be this line here. And the corresponding item code is item code 2. So let's go ahead and type in a value of 2 there. And now as for our time value, you may have again seen my previous video. I recommend viewing the one on transient displacements, the one regarding how to impose a design constraint. I discussed the differences between typing in max, typing in min, so on and so on. Here, per my objective or optimization problem statement, I want to constrain the minimum value only. So we'll type in min here. On the right are my new design constraints, so I'll go ahead and copy these. I'll relocate these to my design model, and I'll paste it right here in the BDF file. And let's go ahead and perform the optimization. And let me redo this optimization example again. Let me actually close Patran and maybe try it again. The reason I do this is my machine is already starved of memory. So it was either closing the PowerPoint, the web app, or Patran to free up some more memory for the optimization. And hence I took that action. Here the optimization is finished. Let's go ahead and view the results at the very end. So now I run into this dilemma. Run terminated due to hard convergence at a best compromising feasible design. So this is not what I planned. So now I get to go through the process of inspecting my results and seeing what could have possibly been the issue. So let me scroll until I find my first design cycle. So here we are at the summary following the first design cycle, and I'm looking at the design constraints, and here I see that internal response ID 1 is the constraint that's being violated, and that is value. All right, so let me discuss what's going on. So here, the double asterisk is a pointer indicating which constraint is being violated. So that would be this row I've selected. This corresponds to internal response ID 1. You follow this 1 until you get to the section responses and design model. Here on the left-hand column, you see all the IDs. Look for the one numbered 1. So here you can see that the value of 0 is already violating my bound for that constraint, which is odd. Let's go ahead and look at my design constraint and see if we can figure out why that was. So here I'm constraining the second component, constraining the minimum of pbush 1, and my minimum is negative 200. Let me make sure I'm using the correct item code. So that is 1. And this is TRSTRE, so that it's my transient stress, my minimum, and here just bear with me while I see if I can figure this out in a quick moment. After looking at this for a while, I believe I might have an issue with units. The units I'm working with are Newton's meters, so the stress is actually in pascals, not megapascals. So let's go ahead and adjust our design constraint. So instead of negative 200 pascals, it should be 200 E9. Or megapascals, so that'd be 6. So let's go ahead and take my design constraints and replace the old ones in my design model. I'm going to delete my old files and rerun that analysis. And again, what tipped me off here was that this first constraint was pointing to a value of 0. So it was saying that at time 0, the value of 0 pascals was already exceeding the lower bound, which was kind of odd. So let's go ahead and reload my F06 file and see what we have now. Look at the very bottom. Run terminated due to hard convergence. Okay, perfect. Let me look at the values. Okay, so it was an issue with units. Fortunately, I caught that. So let's go ahead and continue with the example and discuss the results. So here in orange again is the stress over time for the spring. We impose a constraint saying that at no point should the minimum be less than negative 200 megapascals. I made the mistake of using just 200, which was the incorrect unit, hence I had that original issue. After I corrected that, we arrive at this new final design in blue. You can see that the stress in the spring is now it's lower at 0.45 seconds, give or take. It's now at negative 200 megapascals, and my new spring stiffness is 945 newtons per meter. So with that, that completes this tutorial. If you have questions, comments, again, you can always reach me, email me at this email address, and I'd be more than glad to support you in your optimization process. Thank you for watching.